Venn diagrams and validity. Venn diagrams are named after the mathematician and philosopher, John Venn, who popularized them in his book, Symbolic Logic. The purpose of a Venn diagram is to give a visual representation of the relationship between sets, that is, collections of things. Venn diagrams are traditionally drawn using overlapping circles, but other shapes can also be used. So for example, we may have two sets. The set of two-legged animals. And the set of animals that can fly. Humans and penguins would be in the left-hand section, because they have two legs, but they cannot fly. Most birds would be in the middle section, because they belong in both sets, as they have two legs and can also fly. Flying insects, such as bees and wasps, would be in the right-hand section, as they can fly but have 6 legs. However, there is another area on this diagram, and that is the area that is outside of both circles. Anything that isn't an animal with 2 legs, and also isn't an animal that can fly, would be outside both circles. This would not only include animals such as elephants, but also trees and rocks and planets and so on. Anything at all that isn't an animal with 2 legs, and also isn't an animal that can fly. What makes Venn diagrams particularly useful is that they can not only represent sets, but can represent statements about sets. So we may have the statement, all dogs have 4 legs. This statement mentions 2 sets. Dogs. And those things with 4 legs. To represent the statement, all dogs have 4 legs, the section on the left is blanked out to show that there cannot be anything there. If anything was there, it would be a dog that didn't have 4 legs. Remember, we are not interested in whether the statement is true or false. There may well be dogs who have less than 4 legs due to an unfortunate accident. All we are interested in is having a diagram that represents the statement, whether or not it is true or false. If the statement said, no dogs have 4 legs, we would blank out the middle section. Now, let's return to the statement, all dogs have 4 legs. We may be tempted to think that this means there must be some dogs here in the middle section. After all, in everyday language, when you say, all dogs, you will be speaking about all those dogs that do exist. That isn't the way Venn diagrams work. All dogs have 4 legs doesn't tell you if there are any dogs. All dogs have 4 legs is taken to mean all dogs, if there are any, have 4 legs. Some dogs have 4 legs also means something different to what it does in everyday speech. To represent the word some in a Venn diagram, we draw a line in the appropriate place. In ordinary language, some implies more than one. However, in Venn diagrams, some means there is at least one. Don't worry about this. Just think of them as technical uses of the word that differ from the ordinary everyday uses of the word. Since Venn diagrams can represent statements about sets, they can also be used to represent arguments about sets, and can be used to check if those arguments are valid. Remember, an argument is valid if it is impossible for the premises to be true and the conclusion false, or, to put it another way, an argument is valid when, if the premises are or were to be true, then the conclusion will necessarily be true. In this argument, we have the same 2 sets we had before. The set of dogs. And the set of those things with 4 legs. We diagram premise 1 by putting a letter G on the diagram. However, there are 2 places where it can go, so we put it in both, but with a question mark. This tells us that it has to be somewhere, but we don't yet know which section it is in. Premise 2 is diagrammed by blanking out the left section. We could leave the diagram like this, but it is a bit confusing. To avoid these kinds of problems, the convention is to diagram the most general premise first, those that say all, or no, and only then move on to the more specific premise. So, let's do that again. We start with all dogs have 4 legs. And then when we come to diagram, Nasha is a dog, there is only one place to put the G. Now that we have drawn in the premises, we look to see if the conclusion is already drawn in. If it is already drawn in, it means that, assuming the premises to be true, then the conclusion must also be true, and so, the argument is valid. In this case, the conclusion is already drawn in, the G is in the set of things with 4 legs. Therefore, this argument is valid. Now suppose we had this argument. All dogs have 4 legs. Nasha has 4 legs. And so Nasha is a dog. We draw in the first premise. And then draw in the second premise. Once again, there are 2 sections where the letter G can be placed. There is nothing to tell us which one it is, so we put a G in both, with a question mark. Now, we check if the conclusion is already drawn in. It isn't. The diagram says that Nasha may be a dog, but Nasha may also be something with 4 legs, but not a dog. This means the conclusion isn't already drawn in. And so the argument is invalid. Venn diagrams are typically used to represent 2 or 3 sets. It isn't possible to use circles to represent more than 3 sets in this way. The British statistician, Edwards, used these shapes. However, as John Venn himself remarked, as diagrams become more complex, they no longer fulfill their function of giving a quick, visual representation of the relationship between the different sets. Now let's look at an argument using 3 sets. Notice that when we come to write in the second premise, it isn't clear where we should put the great writers who are not famous. To do this, we put the line across the boundary, so that it is in both sections. Remember, some means at least one. So, a line drawn like this means there may be one in one segment, there may be one in the other segment, or there may be at least one in both segments. At the moment, we don't have enough information to say. Consequently, when we come to check if the conclusion is already written in, we notice that the section indicating great writers, who are also women, may be empty. The conclusion isn't already written in. And so the argument is invalid. Now try these arguments for yourself. You can pause the video whenever you need to decide how the diagram should be completed, and whether it shows the argument to be valid or invalid.